With our falling state done, we can now add in our last states, which are the landing states. Originally, the light landing state was the only landing state that we would add in the first part of the series. But with the addition of the falling state, I think it's fair if we add the other two landing states as well. Of course, for the same reason as our falling state, we haven't yet downloaded the two extra landing state animations. So we'll need to do it now. Start by opening up mixamo.com. Make sure you are logged in and your character model is selected. Then in the Animations tab, search for Art Landing. Download it with the FBX for Unity option selected. I'll rename it to not contain the white space it comes with. And also search for Sprinting Forward Roll. Download it with the In Place option enabled. I'll rename it to YBot@Roll. Of course, YBot here will be your selected character model name. When that's done, in Unity, go to the Landing Grounded Animations folder. Then drag the two downloaded animations to this folder. Open both by clicking on the arrow key and control-click both animation clips. Then press Alt-D to duplicate them. Once that's done, remove the imported assets as we no longer need them. Regarding our landing states, we now know that we have three possible states. Light landing, which happens when we fall from a small height, like after jumping or when touching the ground from gliding. Hard landing, which happens when we fall from a higher height. And rolling, which also happens when we fall from a higher height, but only if we have a movement key being pressed. With that in mind, let's start by creating their scripts. To do that, go to the Player Grounded States Scripts folder. In here, create a new folder named Landing. Inside, we'll create 4 new C# scripts. Player landing state, player light landing state, player rolling state, and player hard landing state. Start by opening up the Player Landing State script. Remove the default methods and swap the inheritance from MonoBehavior to Player Grounded State. Generate the necessary constructor. When that's done, go to all of the other landing states and remove their default methods and swap their inheritance with Player Landing State instead, generating the necessary constructor for each one of them. When that's all done, we'll cache our states, so open up the Player Movement State Machine script. In here, we'll create 3 new properties, one for each of the landing states. To do that, type in public player light landing state. I'll omit the set. Then duplicate this property twice and swap the light landing state with player rolling state and player hard landing state. Don't forget to initialize them as well. When you are done, go back to the player landing state script. We will transition to a landing state from an airborne state, which means we can enter the landing state with a movement key pressed. That means that if we let the key go, our onMovement cancelled method callback will be called, and will transition to the idling state. Of course, we only want to transition to the idling state at the end of their animations. So, to remove the current behavior, override the onMovement cancelled method and leave it empty. I'll also add it to an Euretia named input methods. The next thing we'll do is to update the current idling state transitions that were supposed to be to the light landing state. We only need to do it in the jumping and falling states. Thankfully, we have added that transition in our airborne state, so open it up. In here, in the onContact with ground method, swap the idling state with light landing state instead. Of course, we don't really do anything in our light landing state yet. The first thing we'll do is make sure we can't move while in this state, so open it up. In here, override the enter method. Then set the statemachine.reusabledata.movementSpeed modifier to be equal to 0f. I'll add this method to an Euretia named iStateMethods. The reason why we are not doing this in the landing state is because rolling will have an actual speed, as we'll be able to move while rolling. I'll also reset the velocity when we enter this state, as we want to make sure we stand still and don't keep any previous velocity. So, call in reset velocity. And that's all we really need regarding the light landing state logic. So all that's left to do here is to set the transitions from this state. If we take a look at our movement system states, we can transition from the light landing state to idling, all moving states, dashing, and jumping. When the light landing state reaches its last frame, it will transition to the idling state. Whenever a movement key is pressed while in the light landing state, it will transition to the respective moving state, including the sprinting state. At any given moment of the light landing state, we can dash or jump. With that in mind, let's transition to the idling state by overriding the onAnimation transition event method. Inside, type in statemachine.changeState and pass in statemachine.idlingState. Make sure you remove the base method call. For our moving states, we'll have to follow the update method approach, as we'll be getting here through an airborne state like jumping. So, above, override the update method. Inside, check if statemachine.reusabledata.movementInput equals to vector2.0 and return if that's the case. Otherwise, we call in onMove. For our dashing and jumping transitions, because a landing state is a grounded state, they are already set up. That's all for our light landing state, so we can now do our hard landing state. In Genshin, if we fall from a high enough height and land, if there is no movement input key being pressed, we'll enter the hard landing state. In this state, much like our light landing state, we don't nor can move while in it. Let's start by doing that by opening up the player landing state script. In here, override the enter method. Inside, we'll set the statemachine.reusabledata.movementSpeed modifier to be equal to 0f. We'll also call in reset velocity to reset any velocity we had before landing, making sure we don't accidentally move horizontally due to physics. I'll add this method to an Euretia named input methods. That's most of the necessary logic for our hard landing state, and the only remaining logic is regarding the transitions to other states. Because only the falling state will transition to the hard landing state, we'll do that transition after we also add the rolling state. Regarding transitions to other states, if we take a look at our movement system states, we'll be able to transition to idling, running, and dashing. Whenever the hard landing state reaches its final frame, the player will transition to the idling state. Regarding the running state, the way the hard landing state handles moving to a moving state is somewhat different. Whenever we first land, we'll actually not be able to move or press a movement input key. However, at a certain frame of its animation, we'll be able to start moving by pressing a movement input key. This simply means that we'll have to disable the input for a few frames. One thing to note as well is that we cannot transition to the walking state and only the running state. And last but not least, we can dash at any given moment of the hard landing state. Regarding jumping, we cannot jump again while we are on the hard landing state. With that in mind, we'll start with the idling state transition by overriding the onAnimation transition event method. Inside, we'll remove the base method call and type in stateMachine.changeState and pass in stateMachine.idlingState. For our moving states transition, we'll start by overriding the onMove method. I'll add this method to an iteration named reusable methods. Then we'll remove the base method call and then check if stateMachine.reusabledata.showedWalk, and if that's the case, we return. Otherwise, we'll call in stateMachine.changeState and pass in stateMachine.runningState. To call the onMove method, we'll use the movement_started callback. Now, we can do this here even though we can come from the falling state, because we'll be disabling and enabling the movement input, which means the started action will be called when enabling again if a key is being pressed. So, above our onMove method, override the add and remove input actions callbacks methods. Then add a new callback by typing in statemachine.player.input.playerActions.movement.started plus equals onMovementStarted. Don't forget to remove it as well. I'll add this method to an iteration named inputMethods. I'll also rename the parameter to context. Inside, we simply type in onMove. Regarding our dashing state transition, it's already coded in the grounded state. Now, right now we are able to jump because of our onJumpStarted method in the grounded state. So, in our input methods region, override the onJumpStarted method. Then, simply leave it empty, meaning we won't transition to the jumping state. Regarding our movement input, we'll disable it when we enter this state, and then enable it both when exiting the state and at a certain frame of its animation. We need to make sure we also enable it when exiting, because it's possible that we never reach the defined animation frame, in case we decide to do something like dash, which we can at any given frame. So, to do that, in the enter method, type in statemachine.player.input.playerActions.movement.disable. Then override the exit method and type in statemachine.player.input.playerActions.movement.enable. Copy this line and now override the onAnimation exit event method. We'll use this one to enable the input at a certain frame of the animation. So remove the base method call and paste the line we have copied inside. And that's all that's needed for our hard landing state. So next, we'll do our rolling state. Of course, let's first understand what this rolling state is. In Genshin, if we fall from a high enough height and land, if there is any movement input key being pressed, we'll roll instead of hard landing. In this rolling state, we can also move around while rolling. With that in mind, we know we'll need two things: a movement speed and a rotation data. Thankfully, it uses the same rotation as our normal movement, so we don't really need to do anything extra regarding it. We will, however, still need our movement speed modifier, so we'll need to create its data class. To do that, go back into Unity. In here, in the player grounded data folder, create yet another folder named landing. Inside, we'll create a new C# script to which I'll name player roll data. Open it up and remove the default methods and inheritance. We'll make the class serializable as well. Then type in field serialize field range from 0f to 3f public float speed modifier with a private set. I'll default it to 1f. We'll then open up the player grounded data script. Duplicate the stop property and swap stop with roll instead. With that done, we can now open up the player rolling state script. In here, create a new variable by typing in private player roll data. Then in the constructor, type in roll data equals to movement data dot roll data. We can now set our speed modifier, so start by overriding the enter method. Inside, type in state machine dot reusable data dot movement speed modifier equals to roll data dot speed modifier. I'll add this method to an heuristic named iStateMethods. Now our rolling state will keep rolling until its last frame, even if we stop pressing any movement key. This of course means that if we fast press a key, our player will stop rotating, as the move method isn't being called anymore. Because of that, we'll need to add an automatic rotation to it. Thankfully, that's quite simple to do here, so start by overriding the physics update method. Inside, we simply call in rotate towards target rotation. That should take care of it, but let's also add an if stateMachine.reusable data.movement input different than vector_true.0 and return inside. This ensures we only rotate when we are not calling the move method, as our previous implementation will call the rotate towards target rotation method twice while moving. Right now, because we are able to move in the rolling state, and also because we can only enter here if we were pressing a movement input key, our grounded state should sprint if statement will never enter due to its condition. However, in Genshin, we do not keep sprinting after rolling. To fix this, we'll just go to our enter method and type in stateMachine.reusable data.showSprint equals to false. This should take care of the problem and we shall no longer keep sprinting once we enter the rolling state. We'll now take a look at the transitions from the rolling state. Regarding transitions to the rolling state, much like the hard landing state, we can only come here from the falling state. So we'll add that transition when we are finished doing the rolling state. Regarding transitions from this state, if we take a look at our movement system states, we can transition to walking, running, dashing, and medium stopping. Whenever the rolling state reaches its last frame, if there is no movement input key being pressed, it will transition to the medium stopping state. If it reached its last frame but we had a movement input key being pressed, then we will transition either to the walking or the running state, depending on the walk toggle value. In Genshin, it seems that you transition to the walking state a bit earlier, but I didn't like the way it looks, so I decided to transition at the last frame. If you do want to completely replicate it, then you could override another animation event like the enter or exit method and do that transition there. I say enter or exit because we'll already be using the transition event to transition at the last frame. So, unless you kept a variable that will check if we reach the last frame already, it will possibly transition to the other states earlier as well. Feel free to do it as you prefer. We can also dash at any given moment of the rolling animation. Much like our R landing state, we cannot jump in the rolling state. With that in mind, let's start by setting our animation transition event by overriding the onAnimationTransitionEvent method. Inside, remove the base method call and start by checking if statemachine.reusabledata.movementInput equals to vector2.0. If that's true, we can then transition to the medium stopping state by typing in statemachine.changeState and pass in statemachine.mediumStoppingState. Of course, return right after to not call the rest of the code. Otherwise, if we are moving, then we'll just call in on move. Because we are setting the showSprint property to false above, the onMove here will never transition to the sprinting state, so we don't need to override it. Because we are only adding this transition at the last frame, you could also very likely simply transition to the medium stopping state and let it take care of the transitions to the moving states. However, I'll leave them here as they are right now. The dashing state is of course already done in our grounded state. For our jump, let's override the onJumpStarted method and then leave it empty, as we don't want to be able to jump. I'll also add this method to a new region named InputMethods. With that done, all that's left is to add a transition from the falling state to the landing states. To do that, open up the player falling state script. The way the transitions from the falling state to the landing states work is as follows. If we fall from a small height, we'll transition to the light landing state. If we fall from a bigger height, we'll transition to the hard landing state or the rolling state depending on whether we are pressing a movement input key or not. This means that we need to do two things. Get the distance that the player fell and override the onContactWithGround method, as right now it's only transitioning to the light landing state. Knowing that, in reusable methods region, start by overriding the onContactWithGround method and remove the base method call. We now need to know our distance. The way we'll be knowing it is by saving the position of the player when it entered the falling state and then the position of the player when it collided with the ground. Knowing both, we can then subtract the y value of one with the y value of the other, which guesses the vertical distance between both positions. Of course, we should also always make this value positive. This is because the jumping state transitions to the falling state when it reaches its stop point, which means we can fall into a ground that was above our previous ground, which guesses a negative distance. So, knowing that, in our variables area, create a new variable by typing in private vector3 player position on enter. Then in our enter method, we type in player position on enter equals to statemachine.player.transform.position. When that's done, go back to our onContactWithGround method. In here, we'll get the distance by typing in float fall distance equals to matf.abs for absolute, which makes it become positive when the subtraction returns negative, and pass in player position on enter.y minus statemachine.player.transform _position.y. This gets us the difference between the player position on enter and its current position. When that's done, we now need to know what's the distance to be considered a small or big fall. So, to know that, open up the player fall data script. In here, duplicate the existing property and name it minimum distance to be considered hard fall. I'll also make the range be from 0f to 100f and then default its value to 3f. When that's done, go back to the player falling state script. In our onContact with ground method, now check if fall distance is lesser than fall data dot minimum distance to be considered hard fall. If that's the case, we'll call in stateMachine.changeState and pass in stateMachine.lightLandingState. We could instead call the base method here as it is the same as its transition line. But we won't because the base method can be changed at any moment to contain something else. We of course need to return right after to not call the remaining code. Under this, if we hit the minimum distance, we'll either transition to the hard landing state or the rolling state. We'll start with the hard landing state by typing in if stateMachine.reusableData.movementInput equals to vector2.0. Inside, we call in stateMachine.changeState and pass in stateMachine.hardLandingState. We return right after as well. Otherwise, if we have movement, we'll transition to the rolling state by typing in stateMachine.changeState and pass in stateMachine.rollingState. And that's all we need for our transitions. With this, our landing states should now be working. As a tip, if you wanted to add fall damage to your player, this will likely be the place for you to do it. Now, regarding our transition to the landing states, in Genshin, if we have the walk toggle on, we'll not be able to transition to the rolling state. However, that's only true if we are not sprinting. If we are, then we'll be able to transition to the rolling state. So, in our hard landing state transition if statement, add in stateMachine.reusableData.showWalk and not stateMachine.reusableData.showSprint order. This makes it so that if we have the walk toggle on and are not sprinting, we'll transition to the hard landing state. One last thing to do is to set the jump force to the stationary force when we light land, so open up the player light landing state script. In here, in the enter method, we type in stateMachine.reusableData.current jump force equals to airborne data.jump data.stationary force. Saving and going back to Unity, entering play mode should allow us to fall and land well. Of course, until we add animations, we won't be able to fully test our landing system.